Assalamu alaikum. And now we have to start with another topic and another chapter of central forces. First of all, we have to give some introduction. What are the central forces? Central force is the force that is radially pointing, and the magnitude is dependent on the distance from the source. It means that all the force is concentrated on the single point at the center. Examples we can say that are the central forces for them are gravitational forces, electrostatic forces, and spring forces. In this topic, we will learn in detail about the central force and its equations, examples, and fields. Now to discuss that what is central force, the first question arises that what is central force? In classical mechanics, we can say that the central force is defined as the force that is acting on an object which is directed along the line joining the object and the origin. The magnitude of the central force depends only on the distance of the object and the center. Now, we can say that according to the central forces, depending upon this situation, following are the theorems that relate the central force with the angular momentum. First, there is a theorem 1 for classical mechanics under which we are going to study. For an object to have its angular momentum conserved, the object should be subjected only to the central force. And secondly, it can be stated as for an object to have its motion on a plane, the object should be subjected only to the central force. Now, moving up to the another and discuss about the central force. We can say and central force is represented by the symbol F, and as it is directed from the origin to that point with the radial component r, so we can write that F of r, and we can say that the central forces are the long range forces and some of the examples for the central force we can say I have discussed that gravitational force is central force. So it means that in our solar system it acts towards the center of the planetary objects, and for the non-central force we can say that frictional force is the non-central force. Another question arises that why central force is conservative. A conservative force is one in which the work done in moving a particle from one point to another point depends only the positions of the two particles and is independent of the path taken while moving the particle, and central force is the negative gradient of the potential energy. Now moving to the other point to discuss regarding the position of the particle for the central force. First of all, there are some coordinates. In central forces, we discuss about and work according to the polar coordinates. As you know that there are different kind of coordinates: rectangular coordinates, spherical polar coordinates, and polar coordinates. According to the mathematics, the polar coordinate system is a two-dimensional coordinate system in which each point on a plane is determined by distance from a reference point and the angle from a reference direction. We can convert the rectangular coordinates to the polar coordinates. There are some methods and rules. The polar coordinates are special types of spherical coordinates where phi is kept constant, which is the angle of a constant angle, and you can see there is a axis, polar axis, x in x direction and y direction, and there is a angle theta and component r. The axis with respect to which theta is called as polar axis, and polar coordinates are used to consider a motion in a plane. Now calculating for some expressions for the polar coordinates. Here you can see a picture which have a x-axis coordinates xi cap and vertical component yj cap and angle theta for the displacement. Unit vectors are represented for the direction to represent the direction. I cap is represented for the x direction and j cap is the representation of direction in y direction. Now for the polar coordinates, we further expand the coordinates as a theta, theta j cap 90 minus theta is the angle between theta and theta. Minus j is direction in the negative side and j unit vector is on the positive side. As you know that unit vector is always in the increasing direction of the vector. This is the figure we are going to discuss for the polar coordinates to be calculated. To find the polar coordinates, we will solve these polar coordinates. To solve these polar coordinates, we will solve the angles for AR unit vector. That AR unit vector is in the direction of radial component r. So writing as AR unit vector is equal to AR mod cos of 90 degree minus theta I cap plus mod of AR sin 90 degree minus theta j cap. As we know that the mod of unit vector is 1 and cos 90 minus theta is equal to sin theta and sin 90 minus theta is equal to cos theta. So we will write in the above equation AR unit vector is equal to sin theta I cap plus cos theta j cap. Giving that equation A theta unit vector is equal to A theta mod cos theta I cap plus A theta mod sin theta minus j cap. As we know that A theta mod is equal to 1 and substituting this value we get A theta cap is equal to cos theta I cap minus sin theta j cap, and giving that equation number B. Now for the further work we will go on the next step. Now working for the next step for the polar coordinates value, we will take the derivative of AR unit vector. We will write d by dt AR unit vector is equal to cos theta d theta by dt I cap minus sin theta d theta over dt j cap, and for d theta by dt we will substitute theta dot, so that will become is equal to cos theta theta dot I cap minus sin theta theta dot j cap. Taking theta dot common we get cos theta I cap minus sin theta j cap, and we know that cos theta I cap minus sin theta j cap in the previous slide is equal to A theta cap. So substituting this value in this equation we get d by dt AR unit vector is equal to theta dot AR theta A theta unit vector. Rearranging the equation, d theta by dt d by dt AR unit vector is equal to A theta cap the theta dot, and we will write that equation number 1. Now calculating for the A theta, we will differentiate A theta unit vector using the previous value, and differentiating we get d by dt A theta unit vector is equal to minus sin theta, the derivative for cos, that is minus sin theta, d theta by dt for the derivation of theta I cap minus cos theta d theta by dt j cap. As we know that d theta by dt is equal to theta dot, so minus sin theta theta dot I cap minus cos theta theta dot j cap. Taking theta dot and minus common, we get is equal to minus theta dot into sin theta I cap plus cos theta j cap. We know that sine theta I cap plus cos theta j cap is equal to AR unit vector. So substituting this value, d by dt a theta cap is equal to minus theta dot a theta cap, and rearranging this equation we get d by dt a theta cap is equal to minus a theta minus AR cap theta dot, and giving that equation number 2. Hopefully you have understood. Therefore the polar coordinates till that equation you can write down and note all the steps working with the polar coordinate to find the value of AR unit vector and A theta unit vector. Now moving on to the next step. Now with the polar coordinates, first of all we are going to find out the velocity in polar coordinates for the central force. Now as we know that for central force the position vector r is written as r vector is equal to mod of r AR unit vector. Now taking the time derivative for the position vector r, dr over dt is equal to v vector is equal to dr over dt AR unit vector plus r dr dar unit vector over dt. For dr over dt that is equal to r dot, so we will write is equal to r dot AR unit vector is equal to r plus r into a theta cap theta dot. We substituted this value from previous equation B, rearranging this equation for the velocity. V vector is equal to dr over dt is equal to r dot AR unit vector plus r theta dot a theta cap. Giving that equation number 3. Students working with the polar coordinates, here you have understood clearly. Now moving up to the next. Moving up to the next for the calculation of acceleration. Now as we have calculated for the velocity dr over dt, that is the velocity in the polar coordinate, this is the expression for the velocity in polar coordinates, where r dot is called radial component and r theta dot is called the transverse component of the velocity. Now moving up to the next, acceleration in polar coordinates. For the polar coordinates, we write the value. We know that acceleration is equal to dv over dt, that will be equal to d by dt dot r dot AR unit vector plus r a theta a theta cap theta dot, differentiating it equation and applying the product rule. Taking the derivative d by dt, applying the product rule, we get acceleration A vector is equal to r double dot ar unit vector plus r dot dar unit vector over dt plus r dot theta dot a theta cap plus r theta double dot a theta cap plus r theta dot dar over dt. Now substituting the value for dar over dt, and we get that for the acceleration A vector is equal to r double dot ar cap plus r dot theta dot a theta cap plus r dot theta dot a theta cap plus r theta double dot a theta cap minus r theta dot ar unit vector. Now simplifying that equation, we get that A vector is equal to r double dot ar cap minus r theta dot square ar cap plus 2r dot theta dot a theta cap plus r theta double dot a theta cap. Now taking the common, we get a vector, a acceleration vector is equal to, in bracket we will write r double dot minus r theta dot square, closing the bracket, ar unit vector is the common, plus in bracket we will write 2r dot theta dot plus r theta double dot, bracket close, and taking the a theta cap in common and giving that equation number 4. This is an expression for the acceleration in polar coordinates. It has two components, one is the radial component and one is the transverse component. The radial component of acceleration is r double dot minus theta dot square, and radial component of acceleration is 2r dot theta dot plus theta double dot, and the radial component is represented by ar unit vector, and the transverse component of acceleration is represented by a theta cap. Now moving to the next point, central forces. Suppose that a force acting on a particle of mass m is such that it always directed towards a fixed point O or directed away from the fixed point O. We can say that it is kind of centripetal force and centrifugal force respectively. Number 2, its magnitude depends upon the distance of the particle from the point O, the fixed point O, the origin. Now this force is called the central force, and the point O is called the center of force O symbolically. This force is represented as F vector is equal to F of r unit vector. Here in the picture you can see that there are three coordinates x, y, z, and the position vector r, 3x is x, y, z, and the position vector r. Here your unit vector AR is the unit vector along the direction R. Now, as we have calculated these values and discussed that what is central force, you know that central force is of two kinds, that one is an attractive force and the other is unattractive force, or we could say repulsive force. So we can write for the attractive force F of R less than 0 will be attractive force, and this force will be repulsive force when F of R is greater than 0. Now starting with the properties of central force. First of all, we have to discuss about the motion under the effect of central force takes place in a plane. So, as we know that the central force is given as F vector is equal to F of R AR unit vector. If R is the position vector of the particle moving under the central force at any time t, also R and F are acting along the same direction, then R cross F is equal to 0. We know that R cross F is the torque. Here we can say that torque is equal to 0. Now substituting the value for F force F is equal to ma, we get R cross ma is equal to 0. Substituting the value for acceleration A, that is dv over dt, we get R cross m dv over dt. As mass is constant, so taking it out of the bracket, we get m into R vector cross dv over dt bracket close, that is equal to 0. And taking the differential out of the bracket, or we can say that for substituting the value of R cross dv over dt, we know that dr over dt is equal dr over dt, for solving d over dt into R cross v, we get that dr over dt cross v plus R into dv over dt, that results in v cross v plus R cross dv over dt, that gives 0 plus R cross dv over dt, and that is equal to R cross dv over dt. So we can say that R cross dv over dt is equal to d by dt into R cross v. So substituting that value, we get m into d by dt into R vector cross v vector is equal to 0. Now we know that mass cannot be equal to 0, so its magnitude is equal to 0. That we will write d by dt into R cross v is equal to 0. Now finding this value, integrating both sides, we get that R cross v is equal to constant, and that constant is equal to h. You can note that value, that is the cross product between the velocity and the radial component r, position vector r, that is equal to another constant, that is h. We know that the cross product between the two vectors gives another vector that is perpendicular to the both of the vectors at 90-degree angle. That can be that we can prove by the right hand rule. You know, in the cross product, that r cross v a cross b vector will be equal to another product c vector. Here is the same case. As position vector r is always right angle to the constant vector h, so it must lie in a plane that shows that r cross b is equal to another third quantity h that lies on the plane. Second property for the central force is the angular momentum L that should be equal to constant. As we know that r cross v vector is equal to constant, and that is constant is equal to h. Multiplying both sides with m, we get m into r cross v is equal to mh. We know that mass is also constant and the whole product mh will be constant. So the product becomes r cross mv is equal to constant. We know that mv is the linear momentum. So substituting the value for the linear momentum, that is p is equal to mv. So we can write r cross p is equal to constant. R cross B is equal to constant. We know that R cross B is equal to linear momentum L, and that putting the value for R cross B is equal to angular momentum L vector is equal to constant. This shows that the angular momentum for the central force remains constant. Now calculating the magnitude of L, as L is equal to R cross B, substituting the value of mv, P that is equal to mv, we get R cross mv. As mass is constant and substituting the value of velocity vector in polar coordinate, we get r dot air unit vector plus r theta dot a theta cap. We know that r vector is equal to unit vector mod of vector into unit vector. So we will write the value of r vector, that is r ar unit vector. So that equation becomes m into r ar unit vector. Here unit vector is represented by ar cap, and the more magnitude of r vector is r cross into r dot ar unit vector plus ar theta dot a theta cap. Now taking the cross product with the both values, we know that the cross product between the two same vectors is 0. Here we can see that r into r ar unit vector cross r dot ar unit vector. The product between ar unit vector cross ar unit vector is equal to 0. So the first term in that equation will be equal to 0. So the remaining equation second will remain. We will write mr square theta dot into ar cap cross a theta cap. We know that two vector quantities uh, having cross product is equal to the third vector quantity. Same is the case for the unit vectors. We can say that that is equal to k cap. So will write mr square theta dot k cap, and we know that mr square theta dot is equal to theta dot mean velocity. So here angular velocity. So here mr square theta dot will be equal to L. So we will write L vector is equal to mr square theta dot k cap. Now as taking the constant magnitude, or we can say the unit vector value is 1, we will write L vector mod is equal to mr square theta dot, and that angular momentum value mr square theta. We see that the value of angular momentum is the same as is mr square theta dot, and that value is constant. These are the references for your classical mechanics. You can get help with this. Hopefully the topic under central forces we have discussed is very understandable to you. If there is any kind of difficulty, you can ask me. Thank you. Is there any kind of difficulty? You can ask me the question. Hopefully, the whole topic with the starting with the central forces in classical mechanics is very understandable in the lecture. Thank you so much.